the last thing we're going to do is write an equation for a simple harmonic motion. Consider a ball that is bobbing up and down on the end of a spring. Assume that the maximum distance the ball moves vertically upward or downward from its equilibrium is 10 centimeters. Assume that the time it takes for the ball to move from its maximum displacement above zero to its minimum displacement below zero and back again is t equals 4 seconds. Sorry, that should be minimum. With the ideal conditions of perfect elasticity and no friction or air resistance, the ball would continue to move up and down in a uniform and regular manner. What we want to do is write an equation for the simple harmonic motion of the ball. And so what we want to do is take a look at our amplitude. We know our amplitude is 10 centimeters. Then we want to know the period. So it says 4 seconds is when it starts and then ends again. So we know period equals 4. And remember period, let's look at a sine graph. We're looking at sine, and remember that the period is 2 pi over b. So we can figure out the period. 2 pi over b equals 4. So 2 pi equals 4b divided by 4. So therefore b is pi over 2. So to write our equation, this is d equals 10 sine of pi t over 2. So try this example. Write an equation for a simple harmonic motion for which d equals 0 when t equals 0, and then the amplitude is 6 centimeters and the period is 6 seconds. So again, we're looking at a sine function. So for here, we know our amplitude is 6 centimeters. We know that the period equals 3 seconds. So that's going to be 2 pi over b equals 3. And then so 2 pi equals 3b divided by 3. So b equals 2 pi over 3. So then we are going to write our equation. So d equals 6 sine of 2 pi t over 3.